and by the time we're dealing with the New World, of course, we're dealing with Homo sapiens, because very few people have ever suggested that any earlier form of Homo got to the New World than Homo sapiens. Okay, having said that much, you'll recall that we were able to show that with regard to the agricultural revolution and the role that it actually played, it was preceded by a broad spectrum revolution, meaning people had learned to exploit a broad spectrum of wild plant and animal resources. I explained to you how I had started out my career in archaeology by examining every single site report in its original form for the Great Basin region of Oregon, Idaho, Nevada. And what that showed was that there was a preparation internally in the technological area for grinding seeds. Now, of course, 10,000 years ago, these seed grinders were not grinding any domesticated seeds because there were no domesticated seeds yet in the New World, but they were grinding wild seeds. When an environmental change came, they were already prepared to perhaps stay in the same area and spend the winter eating bread rather than bread made from wild seed flour, rather than hunting and gathering animals and plants. Now, in dialectical terms, if we have to look at this entire process, and we have a better place to look at it than the Great Basin, let's say Mexico or Peru, what we see is that people started out in the primitive communist period putting more and more time into anything other than production, because the number one enemy of the primitive communism, a communist, is envy, jealousy, coveting, and these are centrifugal forces within society, if you want to look at it that way, which will tear the society apart if they are not ameliorated. And the only practical way to ameliorate them, as people learned over a period of millions of years, is not to produce too much. If you don't produce more than what every individual needs on a daily basis, then you won't have to worry about any individual accumulating too much stuff. So, we have this process of regulating production in order to minimize production, which will eventually lead to its opposite. And that's dialectics. The leading to its opposites means that in this particular case, people were changing their way of life in such a way that they had more and more spare time, and they could not help but learn more and more about their environment and every aspect of it in some of that spare time and accumulate that knowledge. The point would come when it wouldn't matter what happened next. What was most important is that there was an irreversible release of surplus social product which accompanied the agricultural revolution. Because once agriculture proper is set into motion, that is the domestication of animals and plants, it has a life of its own. And as it does, so does the people are changing too. They have gone from a point where they appreciate having nothing special other than what every other person in that community has, to a point where they have noticed, they can't help but notice, that there's a difference between being well off and not being so well off, and have, some of them at least, have opted in that direction. When that happens, you have a change in the mentality as well as in the technology. We go through that period of chiefdoms, and then all of a sudden we have an irreversible release of social product accompanied by the differentiation of society from ranks into true classes, where some of them have title deed to property and the rest of them have nothing at all. In that way, what you can see has happened is that the original reason for limiting production to what was necessary led inevitably to its exact opposite, to the complete release of surplus social product, accompanied by a change in mentality and the new appreciation of a few people for a ruling class status. That's dialectics and anthropology. Okay, what are we dealing with now when we go to physics? What we're dealing with here is a very interesting situation. The first 300 pages of this book of Lenin's that he wrote in 1908, he devotes to making a clear-cut division between materialism and idealism. In Marxist terms, materialism has certain epistemological foundations, and we're going to talk about those in a moment, but among them are the denial of any supernatural causation. There are no gods, spirits, ghosts, and things like that. and the assertion that the universe is real and objective, and this is important, independent of human consciousness. Lenin used the phrase, which I've always liked, consciousness is the product of matter organized in a special way. Now, in 1908, the real problem was what was led by a man named Ernst Mach and Werner Heisenberg. Now, Ernst Mach is the man that was most important, and he was taken on directly by Lenin in this book, Materialism and Imperial Criticism, and beginning on page 301 of this edition, and the last third of all of the editions, Lenin takes on Mach, and he has to take him on in terms of Mach's argument, which is about subatomic physics as it is then known. Now, one of the points that Lenin makes right away is the problem with this is fundamentally we don't really know what we're talking about, because in 1908 physics was an extremely primitive form. There was no agreement even on the idea of what an atom was, or even if atoms actually existed. Chemists had gotten used to the idea of atoms because of the periodic table, which they were slowly building up, but they were doing it in a different way than the way we would do it now. But at any rate, they had gotten used to the idea that there were atoms, but had very little idea of what those atoms were. Lenin says, in his as he begins his fight with Mach, is the important thing here is that time may resolve most of these problems, because we can assume that science is going to continue to advance, and that pretty soon we'll know what atoms are and electrons and so on. But until that time, we'll have to deal with it in a different way. Well, one of the principles that Mach tried to put his Bishop Berkeley interpretation on, Berkeley, you may recall, is the father of empiricism, and that's what imperial criticism is referring to. And he says Mach is just a dressed up version of Bishop Berkeley. Now, the essence of this idea is that what's real are ideas, not reality. I know that doesn't make any sense, and it shouldn't anymore, but that was the argument. And I don't want to get off into their argument too far, except to say Lenin, page after page after page, devastates the ludicrousness of this idea. One of the things that Mach used in his time to promote the thesis that the subatomic world was unknowable was the Werner Heisenberg's uncertainty principle, which I like to call the absurdity principle. And the essence of that was that Heisenberg said, if we want to measure the mass and velocity of an electron in its orbit at any point, we cannot do that, and we would have to bounce something off of it, perhaps another electron. That would change its mass, that would change its velocity, and therefore, because we can't measure it, it doesn't have any of these things. It doesn't have mass or velocity. Well, on the surface of it, that should be a stupid assertion. Just because you can't measure something doesn't mean it doesn't exist. What it should mean to you, and what it does mean to most people today, is that, well, we'll find a way to do it. A few years ago, a way was found to determine the exact velocity and mass of an electron in orbit without touching it. I won't go into the details of that, but you can read this book if you're interested, and you can also read some of the other things I've written about it. But the point is, that was considered to be a kind of physical law by Heisenberg and Mach, and Lenin took that apart logically in just the same way I have right there. Now, well, what has happened? Why did we call this Materialism and Imperial Criticism 2.0? Because this time we're going to be able to take a look at exactly the same subject matter that Lenin did, but this time we will have what he said he was hoping that science would eventually produce. And in the last 110 years, more or less, where we have gotten that information. And I'm going to show you an alternative model that I published as a consequence of my original research done in the hole. When I got out of that hole, I went to a library in the joint they sent me to, and it had all of these physics books in there. Now, the librarian there was one of these reactionary kind of guards who thought it was funny to play a trick on inmates by filling a library full of stuff that they wouldn't want to read, which might well have been true for most of them, but it was exactly what I needed at exactly the right time. So I spent 10 weeks working up what I had memorized in my mind in those 5 months in the hole. It took me 10 weeks to do it. And then when I finally got out of the joint prison system altogether, I had 4 papers ready to publish, and I did publish them. And this, one of the first things I did when I got out of there was to get a print-on-demand publisher started in Boise named John Ibarra. And I only had to tell this to John once. He was a smart guy. He figured out that he could lease this machine for $40,000, this print-on-demand machine. It's pretty small. It'll fit right on the top of anybody's desk. And he started publishing books, and he published quite a few of them. Now, including mine, the one that you're going to see the cover of here in a moment. So what I'm going to do today is to go through this first model, an alternative model, which incorporates all of the things that we already know about physics. In other words, there are no ad hoc propositions in this presentation of mine. What we do is to take all of these known facts about subatomic particles and explain them in a consistent way. And that explanation, I'm not sure how many of those I'm going to make, but we're going to make this one for sure, because then we'll see how many of you are interested in pursuing this. And if you're interested, then I'll make a few more on this subject matter before we get back to the 2016 version of ABCs and complete the discussion of the Latin American countries from 1974 to the present. Okay, with those initial comments, I want to go over here in a moment to this chart on the left, which is what I call a chart of scientific explanation, scientific investigation and explanation. This chart is also in my textbook, Foundations of Archaeology, which I published clear back in 1976. So you can see that this is something I've been thinking about for a long time. Science has a structure to it. That's what this chart over here shows us. And part of that structure is that we want to divide it into 2 halves, the investigative half of science and the explanatory half of science. So we have the investigation over here, the explanation over there. At the top of both of these is epistemology, which is just the fancy philosophical word for theory of knowledge. Now, I already mentioned to you that in materialist epistemology, we assert that the universe is real and independent of human consciousness. And whereas idealists, whether they be religionists or some other form, such as Bishop Berkeley, take a completely different view. They either have supernatural forces involved or ideas which are just as ridiculous, such as the fact that ideas are primary and that's all it counts, that's all it exists, and it's the real world doesn't exist independently of that. Okay, there are other aspects to materialist epistemology, and if you want to read them, you get my book, New Perspectives in Physics, at Amazon Kindle Books for $2.99, and you can read it there. It's in its 2nd edition there. Now, at this point, on our investigative side of the chart here, we have scientific method. By that, what we mean is the formation of hypotheses, that is, somebody's idea about something, and we test those hypotheses with technique. Now, I didn't use the word theory on purpose, because theory in science means something completely different than it means in everyday talk. In everyday talk, we say, well, he has a theory about this. What that means, he has some ideas about this, a hypothesis. But in science, a theory would be such the general theory in physics, or Darwinian theory in biology, Marxism in social science, something that explains everything within the purview of that science. Okay, having said that, we could form a hypothesis about something. We test it with whatever techniques we think were appropriate. This is a process that could go on from anywhere from a few hours to a few years. Eventually, this testing of our hypotheses generates a series of facts. Now, go back over, but facts do not speak for themselves. So we have to go over to our explanatory half of this, and we take a look at, again, we'll start with epistemology, because every aspect of our explanation has to conform with materialist epistemology. And then the method of scientific explanation is we draw hypotheses about these facts that we have just generated. And these are conclusions. Now, conclusions in and of themselves have to be evaluated in terms of what kind of conclusion they are. We say in the philosophy of science that there are 4 different kinds of conclusions that scientists can come to. The first is deductive, and that's simple enough. The premises make the conclusion necessary. The second is probabilistic. In this case, usually it's because one of our premises is statistical, and that means that the conclusion will have a certain probability factor attached to it. The third is historical. In the old days, when I first started studying philosophy of science, it was more common to call historical genetic. But because we are scientists and genetics has a particular meaning for us with regard to DNA and so on, I prefer using the term historical. And this means that in this line of scientific explanation, any given event is explained in terms of the events which immediately preceded it, so that you could draw a causal connection. And when Marx and Engels were describing the laws of history, of course, they were using all of these forms, but primarily it was historical explanation. And finally, we have a common way of speaking, which is called teleological explanation. The problem with this is that it's not logical in the sense that it explains something today in terms of events that have not yet occurred. A common example would be if a professor were to say to his students, the amniote egg, the reptilian egg in other words, evolved in order that reptiles could conquer the earth. Well, you're explaining something now in terms of something that's going to happen millions of years later. Now, that of course has inherent, obvious, logical problems. There is one way to get around it mathematically, and that is if we want to say that there are 3 dimensions of physical space in a cube, we can go from one corner of that cube to its opposite corner, draw a line, and call that line time, in which case you're getting to a mathematical point where you can jump back and forth. But otherwise, causality requires that item B is set in motion by item A, and so forth. And the process by which this occurs is called process. So we have causality and process. I'm not going to take that discussion any further, but I am going to stop and take this chart down so we can see the next chart. Okay, now, if we postulate that there were originally unity particles which have only 2 attributes, mass and velocity, which is what we're doing in this particular case, because everybody seems to agree that we have not yet gotten to the bottom of the building blocks of matter. Every few years that go by, we get a little bit further down. When I was first studying science, subatomic particles meant protons and neutrons. Now, it wasn't too many years later before we realized that protons and neutrons are made up of other particles, which we call quarks. And I think everybody realizes that these quarks are not the end of the matter either, and that they have to be composed of still another particle. In my model, I predict that what we are going to find eventually are unity particles, and that these particles have 2 attributes. There are 5 possible attributes for a subatomic particle. 2 of them are velocity and mass. So let's say we have our unity particles moving along in the pre-universe stage, and they strike each other. By striking each other, they will throw each other into a curvilinear or elliptical form. So we have now angular momentum. That's a third attribute that we want to account for. Well, if we assume that eventually that these unity particles are going to accumulate on each other, we want to take a look at what a unity particle will actually look like. And what we hypothesize here is that, let's use the figure 1,000 unity particles simply so that we have something to discuss. if we have unity particles and 1,000 of them are agglutinated to each other because of the fact that they've been running into each other, and we start with tiny little specks and they get dust-sized and so on in time, what we're going to see here in this model is that there is a central core to each unity particle, to each of these new genesis particles composed of 1,000 unity particles. Each of these genesis particles has a tight inner core and an atmospheric-like, tractor sphere-like outer core, and that's important because when they agglutinate to one another, we have introduced a fourth attribute, and that is attraction, or what eventually is going to be called gravitation. There's only one attribute left that we have to account for, and we will do that in this chart right here, and that is charge, or polarity. And by charge I mean what we usually call positive and negative electrical charges. Okay, at one time I did a study of how many of these unity particles adhering to each other would be required, how much space they would take into account if we were to account for all of the known universe matter. And the calculation I made at that time, which I'm certainly not married to, and those of you who are future physics students are certainly invited to put something more precise on it, but at the time I thought if we have the diameter of this ultra-dense object which is being formed in space, beginning right here and going out to its outer edge, if that point was the center of the Sun, it would go out to the orbit of Saturn. That's about 9.5 astronomical units. Now, again, for purposes of our discussion this morning, it's not so important about the figures, but it will give you an idea of the scales of magnitude. Now, what happens to these genesis particles, which have been each formed out of 1,000 unity particles? Well, think of metamorphic products in the Earth, and you'll have the idea of what I'm talking about here. If we start in the middle, we're going to have what I like to call mass-emphasizing genesis particles. These are going to be the smallest and tightest of the whole bunch. And then on the outside, we're going to have an expanded volume of angular momentum emphasizing genesis particles, because this UDO is whirling in space. And that intends to expand these because of the centrifugal force. So now we have two distinctly shaped genesis particles composed of exactly the same original unity particles, but now because of metamorphosis and angular momentum, they have changed into these specific shapes. Now, it stands to reason that there has to be a central horizon within this UDO which has equal property exhibiting genesis particles. In other words, it has all 5 of the attributes that we're discussing. Above and below that, there should be still others, which I call charge emphasizing genesis particles. They are slightly different. That's why we call them type 1 and type 2. Well, why are they slightly different from each other? Because those on the top of the equal property exhibiting genesis particle horizon are sharing that property and with the angular momentum expanded volumetric property of the outer layer. And those on the bottom of it are sharing the property with the EPEG of what exists below that, which is the tightly knit one. So what we're going to have is 2 teardrop-shaped genesis particles, and you're going to see how they can be fit together later on. Now, what about the structure of the overall ultra-dense object itself? You'll see here on the chart that we have the top, the northern hemisphere, written as matter, and the southern hemisphere written as antimatter. And if I had wanted to, I could have kept going with the antimatter equivalents of all of these. This is a simple model to understand because you can think of the Coriolis effect. That is, for those of you who may not know it, if you were to go across the equator on a boat and it had a toilet on it and a sink, you would see that in the northern hemisphere the water swirling around in the sink and going down the tube, the pipe, is moving in one direction, and when you cross the equator, it's moving in the other direction. All right, so we hypothesize that exactly the same thing has to happen in the ultra-dense object, and that the difference between these two is in fact what we call matter-antimatter. The essential test for matter and antimatter particles is what happens when they collide with each other. The answer is always the same, whether it's a positron or electron or a proton, antiproton, whatever it may be, is that they dissolve in a puff. There's nothing left. Well, why would that be? Well, since they are composed of unity particles, that are in motion in one direction, down here, and in motion in the other direction, up here, when they intersect with each other, they impact each other and are inside of each other before any interaction can occur. And when that happens, they are moving completely opposite in directions. There's no way for them to adhere to each other anymore, and they disappear in a puff of, well, not smoke, but you could think of it as a puff of nothingness. Okay, now, what I want to do here is discuss this in a little more detail, and then we'll change the chart. So, to summarize this, in the beginning there was a void, and we began with that part of the void that contains unity particles, which will give rise to the four fundamental particles of force. That's what we're looking for. Now remember, I've told you, I think before, that there are four fundamental forces in the universe. Upon this, all physicists agree. There's also a law in physics, which Einstein pointed out frequently to his logical positivist colleagues, which says that every force has to be carried by a particle. That's extremely important. Remember that in our thinking, we have to keep all of these conditions, laws, and rules in our mind every step of the way. That's not easy, and that's why I would never have gotten to this if I hadn't been locked up in a place where I couldn't do anything but think about this stuff for 5 months. Just to conclude that story, let me say that you may recall that 20 years ago there was an explosion in Oklahoma City. It blew up the Murrah Federal Building. I was finishing up this 5-month period in the hole at that time, and all of a sudden the guards completely changed their attitude toward all of us. They started getting friendly for once, and they got scared. They were thinking, boy, this is obviously revenge for Waco. These guys are pissed off at us. We better make things a little bit better for them. In my case, they put me on a bus and sent me to the Federal Transit Center in Oklahoma City. I spent 10 days there, quit smoking, because you couldn't get cigarettes there unless you worked for the guards. And then I went out to Lompoc Camp for 2 years. Didn't smoke out there either. But that federal building explosion did me a little bit of good, even if it didn't do anybody else any good, because it got me out of that hellhole where I was and transferred out to a pretty nice prison camp, which didn't have any fences, and if you wanted to work outside you could, and drive around on your little cart all day fixing the flower beds and stuff like that, which it's good for your health. But at any rate, that's how that part of the story ends up. Now let's go back to our discussion here. So what we said here is that we avoid. One can imagine, however, that we should be in such a void, which is where certain kinds of detection equipment might show us great distances never before seen. We have to hypothesize this idea when we're using mental experiments and we're thinking about what we're looking at. And this would include universes like our own, which had already gone through one or more of the various stages we are about to discuss. Our mission being to concentrate on the first phases leading to the formation of an ultradense object, UDO. Our scanners are searching for accumulations of unity particles, so we begin. Now, the unity particles are hypothesized, as I said, at having a mass of 1/1000th of that of a photon, which is, of course, the fundamental force particle carrying the force of electromagnetism, and travel at a speed 1,000 times the velocity of a photon, that is, light speed, or 186,000 miles per second. Well, now, let me just go over this matter about light speed. First of all, there is no such thing as a light barrier, and there never has been, and we have known for decades that the same exact mathematical equations that Einstein proved that a particle born at a velocity less than that of light can never be accelerated beyond that of light. decades ago it was discovered that the same mathematics would allow the proposition that if a particle is created faster than the speed of light, it can never be slowed down lower than the speed of light. What does that mean in practice? Well, it means that there's nothing keeping mankind, except science and an engineering problem, from building starships that can go immense distances in very short periods of time, such as you see on Star Trek. So there is no scientific theoretical barrier to the existence of faster than light particles, ships, engines become a matter of engineering, and so forth. Now, at any rate, what we want to go on to now, but getting beyond the light speed part, is that what I'm going to propose is that the genesis particles become attracted as a consequence of their structure one to the other, and that some of them act as arms, that is, gravitational arms of the UDO, creating in the process the deformations that we know as fundamental force particles. Gluons, the particle carrying the strong force; W bosons, the particle carrying the weak force; gravitons, the particles carrying the gravitational force; and photons, the particles carrying the electromagnetic force. Further upon UDO explosion, there will be, in addition to the singular force particles, forms of these deformed genesis particles, also agglutinated, and much larger particle forms of these same force particles, which are the fundamental particles of matter. In other words, we have unified the idea of force and matter by showing that the difference between the force particles and the agglutinated matter particles are functions of agglutination and velocity and deformation in this metamorphic process we show here in the UDO structure. Now, respectively, these will be up quarks, which are formed from gluons; down quarks, which are formed from the W bosons; neutrinos, which are formed from gravitons; and electrons, which are formed from photons. So, you can see that these particles, when they explode, are going to become the fundamental particles of fundamental forces, and when those fundamental particles of fundamental forces are agglutinated, they become the fundamental particles of matter. Everything in this universe can be made up of up quarks, down quarks, and electrons. It takes 2 up quarks and a down quark to make a proton. It takes 2 down quarks and an up quark to make a neutron. We know that we know the protons are slightly heavier than neutrons, and that would probably be because they have 2 of these heavier mass-emphasizing graviton genesis particles originating, and those are slightly heavier. So that explains another factor, which is a known fact and unexplained by others so far, which is that protons and neutrons have a slight difference in weight. Okay, let's go to the next point. What is required now is to visualize how a genesis particle looked or looks. Now, it has a strongly de facto agglutinated main body, around which is a lesser tractor sphere. Now, the latter is an atmosphere-like structure around the main body. It is this less densely occupied region around the main body which is the key to several key forms of attraction, and indeed gravitational attraction. When genesis particles touch ever so slightly, softly, tangentially, it is the interlocking capability, the de facto glue-like role of the tractor spheres which send them A. into mutually common center sharing ellipses, or B. into their actual intertwining, adhering, sticking one to another, or C. into a big ellipse far away from the growing commonality mass, so that their apcenter, that is, if you look at an ellipse, you can have 2 points within it. Where the particle going through the ellipse is closest to one of these centers, we call it the apcenter, and when it's the furthest trajectory point in said ellipse, or near to it, we have we have the apcenter, and the alternative is the pericenter. Those are a couple of terms which there's another good reason for you to get the book, so that you can have all of this at your fingertips and you don't have to be writing notes or typing them into your computer madly. The first two are the mechanisms which account in this model for the creation of a large mass object that will lead in time to a pre-atomic, that is, remember, no atoms have yet been formed, a pre-atomic ultra-dense object. The third is the mechanism of gravitation. As the first agglutinates of Genesis particles become big enough that we could see them with the naked eye, if we could bounce photons off them, say dust-sized particles, the process of building a UDO has begun. Dust-sized particles grow to become rock-sized and meteor-sized and rocky planet-sized and gas planet-sized and eventually star-sized, and yet it will continue to grow. As long as the tractor spheres can interlock, and as long as there is space for mutual interparticle ellipsing, then growth will continue. And as I say at one time, I calculated that this might be about 9.5 astronomical units. At any rate, stellar ignition cannot occur. Atoms do not yet exist to be fused. Growth continues like the blob in space. Perfect packing and arrangement continue to be the entropic character. An ultra-dense object is forming. But it's not a black hole, because it has not been formed by the crushing together of nucleon constituents. Remember that nucleons are protons and neutrons, and both are made up of quarks. 2 up quarks and 1 down quark make a proton, 2 down quarks, 1 up quark make up a neutron. In black holes, it is the quarks that are smashed out of the nucleons and pushed together. In this case, quarks have not yet been formed and are at any rate much larger mass particles themselves, composed of 1,000 deformed Genesis particles. Relatively speaking, the black hole is like chewing gum compared to the attractive power of the UDO. The Schwarzschild radius of this original singularity UDO would have been just above its surface, and that surface would have been on an object with a diameter extending, as I say, from our Sun's core to the orbit of Saturn. Fundamental particle precursors. Imagine the metamorphic results of the stratigraphy of the UDO in terms of the way Genesis particles were transformed in shape and structure. In the center, we have what I have termed the mass-emphasizing Genesis particles, which are extremely compacted. In the outer zone, we have the expanded volume. Tremendous centrifugal pressure of the rotating UDO was responsible. Of the angular momentum emphasizing Genesis particles, or AMEGs. In the very central horizon, there would have been the least alteration of the Genesis particles, and so I have termed these equal property Genesis particles, or EPGs. And finally, as I said before, above and below the central horizon, there are 2 zones. Each of these would have particles with developed polar characteristics, because the upper zone gives rise to polarized particles when one has an expanded end, and the lower zone with polarized particles with one compacted end. We can think of them as tear-shaped or drop-shaped, with the only difference being that one would be slightly larger volumetrically than the other. I have called these charge-emphasizing Genesis particles, or CEGs. Think of this. Polarity is really, in this model, nothing more than another form of what we might think of as electromagnetic charge. The polarity of these charge-exhibiting Genesis particles, in other words, is the forerunner of what we're going to call electrical charge. And so now we have accounted for the origin of the attribute of charge. Now, 4, the Big Bang. Heat is motion. Velocity contained is vibratory motion. Genesis particle containment in the UDO was achieved by the 3 forms of mutual attraction we have described as interlocking tractor spheres mutually ellipsing within a closely defined space, and long-distance ellipsing of rivers of Genesis particles, taking the UDO itself as their pericentre. This would account for how a star holds planets in orbit. There are 4 papers to this book, and in the 4th one I expand upon this. The 4th one is called Stars. At any rate, with regard to the first of these 2, and to the degree that their directional velocity is contained angularly by ellipsing or grasping, we have seen created contained vibratory motion, that is, heat. When the inner core of the UDO witnessed pressure sufficiently high to collapse the tractor spheres, that's this one right here, to collapse the tractor spheres of the constituent Genesis particles, that is the mass-emphasizing genesis particles, or MeGs in our chart over there, all of that directional velocity contained as vibratory motion, or heat, is instantaneously released, exploding the center of the UDO. This was the first phase of the explosion, or Big Bang, that created our universe. As we have seen, the genesis particles had been metamorphosed stratigraphically into four general types of precursor products. MEGs become gluons, AMEGs become W bosons, SEGs become photons, and EPGs become gravitons. 5. The aftermath. Almost instantaneously, it would have seemed, after blasting itself apart into these single particles, which are, of course, the four fundamental force particles originating from the stratigraphic deformational products of UD metamorphosis, and into larger mass clumps of original UDO material, some of the individual particles agglutinated, becoming in that process the fundamental particles of matter that we know as up quarks, down quarks, electrons, and neutrinos. So we have unified in this model both matter and energy, and come up with the building blocks of the universe. As the opportunity for mutual impact decreased, that is, as this explosive matter moves out, the opportunity for each of these particles to impact each other decreases pretty rapidly. With the ever-expanding volume of the explosion itself, so did the opportunity for nucleon formation increase. Okay, nucleon formation is two down quarks and an up quark, or an up quark and two down quarks. Once you've got enough space for these quarks to have formed an agglutinate, which occurs as the mass of this thing is just blown everywhere, we have now had the opportunity for the formation of these fundamental particles of matter. With the passage of still more time, and with the relative opportunity of mutual impact between nucleons decreased, so that occasional impact-created nuclei could remain stable. In other words, if we were, as this mass continues to expand exponentially, what we have here is an opportunity where two up quarks could bind with a down quark, two down quarks could bind with an up quark, particularly protons with neutrons, to form hydrogen and helium. Atomic nuclei came into existence. Now you remember that in the real universe, none of these things on the periodic table exist very much. Almost 99.9% of the universe, as far as most physicists are concerned, consists of just two atoms, hydrogen and helium. This important thing to always keep in mind. Now, yet there was sufficient proximity between the single gravitons and these double up quark concentrations to throw the former into elliptical orbits around said protons. With still more time having passed, it had to come to pass that the electrons also would impact gravitons moving in elliptical orbits around the atomic nuclei of hydrogen and helium. As this occurred, so did the, quote, capture, unquote, of said electrons take place. Now we're getting here pretty close to the gyroscopic atom. Electrons would prefer to travel in a straight line. That's their natural tendency, unless they are constrained in some way. The impact with the gravitons could have different consequences if it were not for the inherent property of electrons that flows from their composition. That composition being, as we have seen, is nothing more than an arrangement of photons. An agglutination product of photons is all an electron is. Therefore, upon impact, the electron with a graviton, the electron exudes a photon, a buffering photon to be precise. And these gravitons are now traveling in a gimbal-like orbit around the axis of an atomic nuclei, which in this case is either a hydrogen nuclei, that is a proton, or a helium nuclei, which is two protons, two neutrons. Upon impact, the electron exudes a photon, a buffering photon, to be precise. As it does, it changes the photon's directional velocity from straight line to angular. And since the ellipse itself is rotating around the atomic nuclei at light speed, or slightly less, while its constituent gravitons of the ellipse are traveling at, say, 100 times light speed, the effect is to continually constrain the electrons into their own nearly circular, but not quite, elliptical orbits. Thus were created the first true atoms. Hydrogen and helium nuclei took on electrons as a consequence of their pericenter role for light speed rotating elliptical streams of superspeed traveling gravitons. Now I'm going to change this chart over here so that we can get to the next point. For just a moment, let's review the origin of force in matter particles. Our charge emphasizing Genesis particles are on top. When they agglutinate after this explosion, they form photons, which are the fundamental force particle carrying the electromagnetic force. When they agglutinate, they form electrons, which is one of the three basic particles that create all known matter in the universe. The mass emphasizing Genesis particles at the center of our drawing that we were looking at before become gluons, which are the particles which are the fundamental force particles of the strong force, and when they agglutinate, they form the fundamental particles of up quark, the second of the three most important particles which create all known matter in the universe. The AMGP, that is the angular momentum emphasizing Genesis particles, form the W bosons, which are the particle that carries the weak force. And the weak force, when they agglutinate, form a down quark. Now, what does the weak force do? It binds nucleons, that is, for example, atoms and protons and neutrons, together. What is the strong force? That's that's the force that binds together the quarks within the nucleon. Okay? Now, there's only one thing we have left to account for, and that is neutrinos. So we know these neutrinos exist, and we keep getting readings which show that they travel at velocities in excess of that of light, and this has thrown many physicists for many years into one tizzy after another because of their misunderstanding of Einstein's theory of light barrier. But as we have already seen, there's no such thing as a light barrier, so there's no problem in theoretical physics with particles that go faster than the speed of light. And in fact, they have been named for a long time as tachyons. So when you're looking at a Star Trek show, for example, and they're talking about tachyons, they're just talking about particles that go faster than light. Now, in this model, the equal property emphasizing Genesis particles agglutinate upon explosion into gravitons that are traveling at a speed of 1,000 times, let's say, that of light, which when they agglutinate one to the other, they form neutrinos, which are mass particle, and which are traveling at 100 times the speed of light. Why is it we've had so much trouble detecting them? Because our detectors, just like everything else on the Earth, are composed of particles which cannot possibly react to something that goes through them many times faster than their ability to react to them. These neutrinos travel through the Earth uninhibited for practical purposes, and of course so do the gravitons, and they're uninhibited because they're through the Earth faster than any interaction with them can occur. So that accounts for that. We'll talk more about these later. Notice also on this chart that we have accounted now for 5 basic attributes which have to be accounted for some way or another for all of our fundamental force particles: mass, velocity, angular momentum, attraction, which is another way of looking at gravitation, and charge. I'm going to take this chart down now. What I've decided to do here is to use the chart which is on the cover of the first edition of this book. This book is now available in second edition at Kindle books. At any rate, you'll notice that we have 2 gimbals going around a center. That's why I call it the gyroscopic model. The first one, in red, traveling vertically, is a stream of gravitons, which themselves are moving at a speed of about 100 times that of light, according to this model. But remember, these are just figures that we plugged in here to give a difference of order of magnitude, so for you to think about. Actual velocities will be determined by other physicists later. long after I'm dead probably, but at any rate, now, then we have another gimbal, which is the electron orbital, which is here, and it's shown in yellow. Now, the graviton orbital itself, this one, rotates around a nucleus. And if I drew a line from there, it would be over here just to show that this red ellipse itself is rotating at near light speed. And this is the axis of the graviton orbital. The electron orbital is here, and the point of articulation between the two is here and here. Now, this is an important factor. There's a law in physics that we've known about for a long time called the Pauli exclusion principle, which says that no orbital can have more than 2 electrons. Well, why would that be? Well, nobody's ever explained it, but this model does explain it. Because at this particular point, when the electron impacts the graviton stream, it exudes what we call a buffering photon, as I've said, and that buffering photon is then carried to the other side, where it's redeposited on another electron. But there are only 2 points of intersection, so that would account why you can have only 2 electrons in any given orbital. So this model also explains the Pauli exclusion principle. Now, there was something else I wanted to mention here with regard to this. Oh, yeah. Now think of the electron structure itself. Remember, I've said several times that in this model, an electron is nothing more than agglutinated photons. So one of the easiest things in the world for an electron to do upon impact with a graviton is to exude a photon, which buffers that impact. We can also call these magnetic photons because they go up and around like this, and it's these which form the magnetic lines of force in Faraday's old experiment. And in a future lecture I'm going to show you what Faraday's experiment was all about. But I'm going to stop right here in our discussion of the gyroscopic atom because I'm running out of time, and we still have a lot of material to go through. I'll talk to you more about how this gyroscopic atom works. To relate it again to Lenin and his book, Materialism and Empirio Criticism, I can't tell you how important it is for you to go back and study that entire book from cover to cover. And in the last third of it, you'll see how he's constantly saying, well, this may get resolved as scientists get us more facts. Well, we have the facts. I'm not saying that my model is the only way to use them. I am saying it's one that I spent 5 months developing and then another few months writing it up when I had library facilities. And it represents the best of my thinking. On the other hand, my PhD is in archaeology. This subatomic physics is just a hobby. So this needs to be picked up by people who are willing to learn to think dialectically and to get past the general model that physicists use. What's the problem with the general model as it stands? Well, the biggest problem is it's written by people who don't know how to think scientifically. That is, they don't know dialectics. That's the biggest problem of all science. Of course, most obviously social science in North America, but as you can see, it's also holding back physics. If it wasn't for that, we'd already have an anti-gravity engine. We'd already have engines moving faster than the speed of light and so forth. Well, enough on this tape, and we'll go on with this in 27B.